We will start at 4, okay? Okay, I will share the slides now. I hope everyone have gone through the lectures. I will be discussing few problems based on electrocyclic reactions today. So it is better that if everyone have gone through the slides. Are you able to see my slides? You can unmute and tell because I will not be able to see the chat box now.
Yes, we can see.
Okay. So welcome to week 1 tutorials of NPTEL PMRF tutorials of pericyclic reactions and organic photochemistry by Professor S. Shangararaman from IIT Madras. Myself Anisha Suresh, PMRF scholar from IIT Bombay. So today we will be discussing regarding the week 1 modules. So here important point that we have to remember is regarding the Woodward Hoffmann rules for electrocyclic reactions. So sir have discussed regarding this, and for foreign system, that is a system involving number of electrons foreign, like a 4 electron system, 8 electron system, etc. If the mode of rotation is conrotatory means if the rotation is in the same direction. Conrotatory means rotation can be either clockwise or it can be anti-clockwise, but it should be in the same direction. So in the case of foreign electron system, thermally it is allowed and photochemically it is forbidden. And in the case of foreign electron system like 4 electron, 8 electron, etc., this rotatory means both are in opposite. It could be towards inward or outward. So thermally it is forbidden. Disrotatory rotation or the mode of reaction in disrotatory fashion is forbidden thermally, but it is allowed photochemically. Similarly, for 4 n plus 2 electron system like 6 electron, etc., conrotatory process, that is rotation in the same direction, it is forbidden, whereas photochemically it is allowed. And in the case of 4 n plus 2 electron system, this rotatory reaction mode, so it is allowed in the thermal condition, whereas it is forbidden in the photochemical condition. This is clear for everyone, right? Sir have discussed it in detail in the lectures. So coming towards the first question, so it is based on electrocyclization. Predict the orbital involved and rotation it goes through in the following cyclization reaction. So here a 4 pi electron system is given. So they are asking about the orbital that is involved in the reaction and the mode of rotation that will be taking place here. Answers. So it is thermal condition, and in thermal condition the ground state configuration will be involving. So in the ground state, what will be the HOMO of this 1,3-butadiene system. What is the HOMO? So that HOMO will be involved in the reaction.
Side 2.
Side 2 will be the HOMO. So side 2 will be the HOMO, and it is 4 electron delta thermal condition. So what will be the mode of rotation? Conrotation or disrotation?
Conrotation.
Yeah. 4 electron thermal system, it will be conrotation. So if we are writing, this is our system. So delta condition, it will be conrotation. So if we are rotating it in this fashion, clockwise fashion, the hydrogen here will be going upwards, that is, it will be beta. Similarly, the hydrogen here will be beta, and both methyl can be alpha. And if we are rotating it in this fashion, anti-clock fashion, this methyl will be going towards upward, so it will be coming beta. This methyl will also be going towards upward, it will be coming beta. So the product can be either both are beta or both are alpha. Clear, right? So here we have been given the answer as beta. It could be alpha as well. So the correct answer is side 2 conrotation. So answer is A. This question is clear to everyone, right? We have to apply the basic concepts of Woodward and Hoffmann rules in this. So we will be able to answer. Now coming to the second question. This is a question from JAM 2021. So the major product formed in the following reaction is. So here a 6 electron system is given, and the condition given is delta. So 6 electron means it will be 4n plus 2. 4n plus 2 delta means mode of rotation. What will be the mode of rotation?
Disrotation.
Yeah. So according to Woodward Hoffmann rules, 4n plus 2 delta, it will be disrotation. Mode of rotation will be disrotation. So here we are having a 6 electron system, and two methyl groups are there which are in trans fashion, E system. So this is a 4n plus 2 system, and the condition is thermal, so it will follow disrotation. Disrotation means either both of this will be moving inwards or both of this will be moving outwards. One will be clockwise rotation, one will be anti-clockwise rotation. So if this methyl is moving inwards, it will be coming above the plane. Similarly, if this methyl is moving inwards, it will be coming above the plane, and the hydrogen will be coming below the plane. So a six-membered ring will be formed, and double bonds will be shifting here, and the methyl groups will be above the plane if the rotation is taking place in this fashion, and if the rotation is taking place in this fashion, the medial groups both will be going downwards. So the correct answer will be answer B. If there is an option where both the medial groups are in alpha position, you can answer both of those. Since only one correct answer is given here, you have to choose this as the correct answer. Okay? Any doubts? Someone have raised hand? Anusha? Any doubts? So the right answer for this question will be B. Following the Woodward Hoffmann rule, for 6 electron system, it will be 4n plus 2. And here it is given 170 degrees Celsius. 170 degrees Celsius means thermal condition. So 4n plus 2 thermal. 4n plus 2 thermal means the mode of rotation will be this rotatory. If we follow that, we will be getting B as the correct answer. Any doubts? I hope it is clear. Now we will move to question number 3. So this is a question from CSIR NET December 2011. So the final product formed in the following reaction will be. It is an electrocyclic ring opening reaction. So this four-membered ring, because of its ring strain, it will be opening up under thermal condition. So what is the number of electrons involved in this reaction? Hello? So we will be considering this four-membered ring. So what is the number of electrons that will be involved in this reaction? Anyone please answer?
4,
Yeah,
4 electrons.
it is a 4 electron system. 4 electron system, and the condition is delta. So if it is 4n system and delta, what will be the mode of rotation? 4n delta. Is it conrotatory or disrotatory according to the Woodward Hoffmann rules?
Conrotation.
Yeah, it will follow conrotation. So we will see how to get the answer. So we are having a benzene with cyclobutene, and one of the medial is above the plane, one of the medial is below the plane, and it is delta. So we have seen 4n delta is conrotatory according to the Woodward Hoffmann rules. Conrotatory means it is either both clockwise or both anti-clockwise. So if we follow both clockwise, Here the medial group, which is above, if we rotate it in clockwise fashion, it will go inwards to the ring. And this medial, if we rotate this medial, which is below the plane, if we rotate it clockwise, it will go outwards the ring. So if it is above the plane and we are rotating, it will go inwards the plane, and this hydrogen, medial will be going inwards and the hydrogen will be going outwards. So both the medials will be coming inwards if we are rotating it in clockwise fashion, and both the medials will be going outwards if we are rotating it in anti-clockwise fashion. This is clockwise rotation and this is anti-clockwise rotation. Clear how we are getting the products? So we are following the basic Woodward Hoffmann rules. So we have seen this is the system that is involving here. It is a foreign system, and the condition that is given is thermal condition delta. So foreign delta, it will follow conrotation. So conrotation can be either both will rotate clockwise and both will rotate anti-clockwise. So if we rotate both of this medials in clockwise direction, it will come towards inward the double bonds. And if we rotate both of it in anti-clockwise fashion, it will go outwards like in trans fashion. So these are the two products that we could get from this reaction. And here option B and option C, both are the correct answers that we could get. Both are the final products that we will get from this reaction. Is it clear?
Yes.
Okay. So both B and C are the right answer for this question. Now we will be moving to question number 4. So what is the major product that is formed in the following reaction? This is a 9-membered cyclic system, and here we can see 6 pi electrons are involved. 6 pi electrons, which means 4n plus 2 system, and the condition is delta, thermal condition. So what will happen? 4n plus 2 delta, whether it is conrotatory or disrotatory.
Disrotate.
Yeah, 4n plus 2 delta means disrotation take place. So we will see it is a 9-membered ring. So here we can consider these hydrogens. Sorry. 3, 4, 5, 6, 7, 8, 9. This is the 6 pi electron system, and the condition is delta. So 4n plus 2 delta, we have seen it as this rotation. So if we are rotating in this fashion, the hydrogen will be coming above the plane, and that side also the hydrogen will be coming above the plane. So if we are rotating in this fashion, the hydrogen which is outside this double bond, it will be coming above the above the ring. And here this hydrogen, if we are rotating it in this clockwise fashion, it will be coming above the ring. So we will get a six membered ring. 1, 2, 3, 4, 5, 6. A bond will be formed between these two, right? A bond will be formed between these two, and there will be a 1, 2, 3, 4, 5. 5 membered ring that is fused to this. So this hydrogen, it will be above the plane, and the other hydrogen will also be above the plane. If we are doing this rotation in the other fashion, both of the hydrogens will be coming below the plane. So the right answer will be option A. Clear? Any doubts? Hello?
No, ma'am.
Okay. So the right answer is option A. So this is also a question from CSIR NET. Next question is the number of pi electrons participating and the pericyclic mode in the following reaction are. So here we have been given an octatetraene system and it is heated. So it is a thermal condition, and this is the product that we are getting. So based on the product that we have obtained, we have to tell what is the number of electrons that are participating in this pericyclic reaction, and what is the mode of the following reaction. That is, either it is conrotatory or it is disrotatory. So based on the product that you obtain here, what can you tell about the number of pi electrons that will be participating in the pericyclic reaction?
Be 6.
6 electrons will be involved because one, this one, and this one will be involved. This is remaining as it is. It is coming in the 4-membered ring. So we will see. So it is a 6 pi electron system and delta. 4n plus 2 delta. What will be the mode of rotation?
Well, it will be disrotatory.
4n plus 2 delta is disrotatory. So we have seen it is a 6 pi electron system and the mode of rotation is disrotatory. So the right answer will be option D, that is 6 and disrotatory. Now we will see the mechanism of this reaction. So it is an 8-membered ring. Octatetraene, and it is heated. So this part of the system or the cyclic molecule will be taking part. 6 pi electrons will be taking part. So we have seen it is disrotatory one will be anti-clockwise and one will be clockwise. So this hydrogen, if it is moving in clockwise fashion, it will come above the plane, and this hydrogen, if it is moving in anti-clockwise fashion, it will come above the plane. So we will get a six membered ring, and here a four membered ring will be fused with it, and both of these hydrogens, it will be coming above the plane. And if we are following this rotatory fashion in the opposite, like if it is anti-clockwise and this is clockwise, then both the hydrogens will come below the plane. So this is the mechanism for this reaction, and as we have seen, it is involving 6 pi electrons, and it is following a disrotation. Clear, right?
Yes, ma'am.
Okay. Now coming to question number 6. This is also a CSIR NET question from June 2016. So the following transformation proceeds through two consecutive processes, which are, so it is a delta thermal condition. So first what will happen? So this reaction is taking place in two steps. First, some sort of electrocyclic reaction is taking place, and then again another sort of electrocyclic reaction is taking place. So, what are those two processes? And like whether it is disrotation, conrotation, number of electrons involved, that we have to predict.
Ring opening.
First, it will be ring opening. So, how many electrons will be involved in that? So, for ring opening, we will be considering this four membered ring. So, here there will be a pi bond and these two and the sigma bond that will be involved. So, it is a 4 electron system, and 4 and delta, it will be conrotatory. Next, we will see what is the product of this reaction, and based on that, we will be able to predict the next step. So, first, we will see the mechanism for that. This is delta. So, 4 and delta conrotatory. Both should be rotating in the same plane, and we will get double bond, double bond. So here what you are having? You are having a 6 pi electron system, right? Are you able to see? 1, 2, 3. 3 pi bonds. So it is a 6 pi electron system, and the condition they have given is delta. So it will be 6 pi delta. What will be the mode of rotation?
This rotation.
Yeah, it will be this rotation. So here, if we are considering, it will follow this rotation. This double bond will shift, this double bond will shift, and a new sigma bond is formed. So this is the product. So here what first step it is involving foreign electrons and conrotation, and in the second step it is involving 6 pi electrons and disrotation. So according to our question, the following transformation proceeds through two consecutive processes, which are 4 pi conrotatory and 6 pi disrotatory, right? The first step is involving conrotation and the second step is involving disrotation. Any doubts? Now coming to the seventh question. This is from GATE 2015. So here the major product formed in the following reaction will be. This is also similar to last question as we have seen, but here stereochemistry is involved. In last question, stereochemistry was not involved. As you can see, here there is no stereochemistry elements that are given, but here stereochemistry elements are given. So what will be the product of this reaction? You try solving it out, then I will discuss the mechanism. So first, as we have seen, this cyclobutane ring will be opening. A ring opening will be taking place, followed by electrocyclic ring closing. So in the first step, it will be 4 pi electron conrotation, and in the second step it will be 6 pi electron disrotation. Are you able to get the answer? Anyone? I will work out the mechanism. So this is our starting material and we are applying heat. So it is a for an electron system, conrotation will be taking place. So conrotation means both of them will be rotating in the same direction. So we rotate it in this fashion. So once it is opening, what will happen? It is moving anti-clockwise. So whatever is above the plane, it will come inside, and whatever is, and this one, here we can see there is an hydrogen, it will be going outside and the methyl group will be coming inside. Both are rotating in the same direction, right? So if we rotate this group which is above the plane, it will come inside anti-clockwise fashion, and this hydrogen it will be moving outside of this double bond. So this methyl group will come inside. So we will write like methyl, then this, and there is a double bond. So here both of these methyls are cis to one another. It is given in the question, right? Both of this methyl groups are in cis fashion. Now we got a 6 pi electron system. 6 pi electron system. So it will follow in delta disrotation. So if one is moving in, we are considering here. If one group is moving in this anti-clockwise direction, the other one will be moving in clockwise direction. So the methyl group which is inward, it is moving clockwise direction, it will be coming below the plane, and this methyl group which is outwards, if it is rotating it in anti-clockwise direction, it will come above the plane. And these bonds will shift in this fashion. So we got another 6-membered ring fused with this, and a new double bond is forming here. There is a methyl group next to that on that double bond, and this methyl group is going below the plane, and this methyl group is coming above the plane. Or it could be like this. If we do this rotation in the other fashion, like here we have done in this fashion, if we are following this sort of this rotation, then we will get this product. Green rotation, we will get this product, and this blue sort of rotation, we will get this product. So the right answer according to this question is option D. Able to get? Able to follow? Hello? If you are responding, I will be able to get if you
Understood.
are understanding. Yeah, tell Fatima. Any doubts? Okay. So now coming to question number 8. So this is Nassarov cyclization which sir have discussed. The final product of the following reaction will be. What will be the final product of this reaction? So this is the Nassarov cyclization. So I will briefly discuss the mechanism of Nassarov cyclization. So here in the presence of a proton, here we have been given a proton source. So in the presence of that, this oxygen will abstract this H plus and it will form OH plus. Then this bond will break for neutralizing that positive charge on oxygen and we will get a positive charge here. So here there is OH. Now what is happening? This is a cyclopentadienyl cation kind of system or allynyl cation kind of system. Now what will happen? This this bonds will be shifting in this fashion so as to get a 5-membered ring. So here total 4 pi electrons are involving 4 pi electrons and the condition is delta. So it will follow conrotation. So if we are drawing arrows, we will draw according to conrotation. And now for neutralizing this positive charge, here the electrons bond is shifting from this side to this side. So here a positive charge will be developing as it is shown here. So for neutralizing that, this proton will be lost and we will get a diene here. Now this is an enol. It will tautomerize to ketone and we will get this as the product. So now our question is like this. It is similar to that whatever mechanism we have seen. So we will see what is the product that we will get. This is our question, right? So it will abstract H plus and it will form OH plus. Now this bond will shift to this side. It will neutralize this positive charge next to OH and a positive charge will be developing over here. OH double bond. Here a new bond will be forming. Here a positive charge will be developing. Now for neutralizing this positive or this carbocation that is formed, an elimination of proton will take place and we will get OH double bond. So a diene kind of system will be forming here. This is an enol. So this enol will tautomerize to ketone. So we will be getting an enone system here. So the right answer here is option B. Were you able to follow the mechanism? Any doubts? Hello?
No, ma'am.
Okay. the answer is B. Now, here is a reaction, the electrocyclic reaction that is given. So, determine the number of electron pairs in this reaction, the type of rotation, and whether the reaction is allowed or forbidden. So, looking at the starting material and the product, you have to predict the number of electron pairs that is involved in the reaction, the type of rotation, whether it is disrotation or conrotation, and tell according to Woodward Hoffmann rules whether the reaction is allowed or forbidden. Anyone? Can anyone tell the number of electron pairs that will be involved in this reaction?
Two electron pairs. No?
It will be 4 electron. You have this is a cyclobutene system. So these pi electrons and the sigma electron, it will be involved. You can see the product for reference. So here 4 pi electrons will be involved. So the number of electron pairs is 4. Then the type of rotation. Here, not according to Woodward Hoffmann rule that you have to tell. You have to see the product and tell according to that. Then only we can tell if it is allowed or forbidden. So this group which is above the plane, it is going like it is coming trans to the double bond. So it is rotating in this fashion, in clockwise fashion. And this hydrogen which is above the plane, it is coming like inside the double bond or inside the system. So it is also rotating in clockwise fashion. So the both are in clockwise. So the type of rotation is conrotation. Right. So we have 4 electron system, thermal, and it is conrotation. So according to Woodward Hoffmann rules, whether it is allowed or forbidden. Foreign, thermal, conrotation. It is allowed or forbidden according to Woodward Hoffmann rules.
Allowed. No?
It is allowed. So this is a detailed solution for that question. So we have usually analyzed this type of reaction from the other direction. That is, we were previously seeing that diene is converted into cyclobutene. So here we are breaking the cyclobutene and converting it into diene. So how it is involving? As we can see, this is involving a conrotation. This is the plane. It is if it is rotating it in clockwise fashion, it will go outside the double, like it will come in trans fashion, and it is this hydrogen is above the plane, and if it is rotating it in clockwise fashion, it will be coming inside the double bond. So this is the conrotation that is involved. So however, the same analysis work for either the direction of the reaction. In the case an even number 2 of electron pairs are involved, the sigma bond and the pi bond of the reactant are converted into 2 pi bonds of the product. That is why we are considering it as a 4 electron system. Okay. The sigma bond and the pi bond of the reactant are converted into 2 pi bonds of the product. So, and the reaction occurs by conrotation. then we can see according to Woodward Hoffmann rules it is allowed. And under photochemical reaction, the same reaction will be forbidden. 4 electron, if it is H nu, conrotation is forbidden. Now here two reactions are given in similar fashion as you have solved question number 9. In similar fashion you have to solve these two questions that is given here in question number 10. Indicate the number of electron pairs and the type of rotation for these reactions and determine whether each is allowed or forbidden. For A, anyone can tell what is the number of electron pairs that are involved here?
Two electron pairs.
2 electron pairs, so it is 4 electron system. And the type of rotation that is involved here, you have to say it is H nu, and type of rotation involved. This double bond is coming above the plane. From outside it is coming above the plane, so it is rotating in anti-clockwise fashion, and this from outside it is coming above the plane as you can see, so it is rotating in clockwise fashion. So this is disrotation, right?
Yes, ma'am.
So for electron system, disrotation and H nu, is it allowed or forbidden according to Woodward Hoffmann rules?
It is allowed, ma'am.
Yeah, it is allowed. Now coming to question number B. So here they have given, this is the system CH3 and CH2CH3, that is ethyl. And the condition given is delta, and this is the product that they have given. CH3 is above the plane and ethyl is below the plane. So what is the number of what is the number of electrons that are involved in this reaction?
6 electrons, ma'am.
6 electrons are involved, and it is thermal condition. And now this is the product that is given, so we will see what is the mode of rotation. This is outside, it is coming above the plane, so it should rotate in anti-clockwise fashion, and this it is coming below the plane. So for coming below the plane, it should rotate in anti-clockwise fashion. This hydrogen will come above the plane and this ethyl will go below the plane if it is rotating in anti-clockwise fashion. So this is conrotatory. Right, both are rotating in the same direction. 6 electron conrotatory delta. Is it allowed or forbidden according to Woodward Hoffmann rules? 4n plus 2 delta conrotatory. It is allowed or forbidden according to Woodward Hoffmann rules?
Forbidden, ma'am.
Forbidden.
Yeah, it is forbidden reaction. So that is why they have given here a reversible arrow. So this was the last question for today's tutorial. Are you having any doubts regarding any of the questions or any doubts in the lectures?
No, ma'am.
Clear, right? So thank you all for spending your time for listening my tutorials. So we can meet next week 4 o'clock for week 2 tutorials. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you.